Welcome to Homework Lib.
Hi, in this program we're going to have a solid that is going to decompose into ammonium and H2S as a gas. So the concentration of NH3 gas that we have at the very beginning, it is going to be equal to the amount of mole divided by the volume of the container. So we have 0.4 mole divided by 2 liters. This is the concentration, giving us a value of 0.2 mole per liter. Recall that this is the definition for molarity, that is amount of mole divided by the volume in liters that we have. Next up, we need to consider the solubility, the product of the following reaction. We're going to have the decomposition of this solid to produce NH3 gas plus H2S, same thing as a gas. And we are told that the value for Kc for this reaction is going to be equal to 1.6 times 10 to the minus 4. So, if we go ahead and proceed with our ice table, first of all, the initial amount of solid, it doesn't matter, but we know that a portion of the solid it is going to decompose, that is going to be minus x. Initially, my concentration of NH3 gas is equal to 0.2 molar, and of H2S is going to be 0. So over here, we're going to have plus x in both of these quantities. At equilibrium, thus, the solid doesn't matter, but I'm going to have 0.2 plus x of NH3 and x of H2S. Next up, we can write down the definition for our equilibrium constant, that is concentration of NH3 times concentration of H2S. It's going to be equal to the values that we found at equilibrium. So 0.2 plus x times x. This is going to be equal to the value for Kc, that is 1.6 times 10 to the minus 4. So now, what we are going to do is take the approximation that 0.2, it is going to be much larger than the value for x, because we know that Kc is a small value. Under this approximation, our equation becomes, instead of having 0.2 plus x, this is going to be equal to 0.2. So Kc, that is equal to 1.6 times 10 to the minus 4, will be equal to 0.2 times x. So the value for x that we want to get, it is going to be equal to 1.6 times 10 to the minus 4 divided by 0.2, giving us 8 times 10 to the minus 4. Now let's look up what is that value of x. That is the concentration of H2S and the additional value of NH3. So let's write down this thing again. Concentration of NH3 gas, it was 0.2 plus x. This is going to be equal to 0.2008 molar. The concentration of H2S gas is equal to x, equal to 8 times 10 to the minus 4 molar. And those are going to be our concentrations after we reach equilibrium. And that would be all. Thank you very much.